All right, so again, 7.1 is called linear and nonlinear systems of equations. So you're getting linear, which means lines, right? Which means variables raised to the first power. And then nonlinear, where you could get things like parabolas or cubic functions, that kind of stuff. And today we're going to talk about solving using substitution and solving using graphing. And then 7.2, we add an elimination. So this just starts by saying the system of linear equations. Two linear equations are called a system of linear equations. So you have two variables, two equations. A solution to a system of linear equation is two variables in an ordered pair that satisfies both equations in the system. So one, we know what a solution is. If we take those, we have to plug them into both equations to check. That's the first thing. Second thing is when you provide your solution to me, you'll give it to me in an XY coordinate form. So you'll do it in parentheses XY coordinate. So this first one is just to check, right? So it says determine if the ordered pair -1, 3 is a solution to the system. So the -1 is my x, the 3 is my y, and I just want to plug them into each one. So if I start with the first one, 2 times -1 minus 3 equals -5. -2 minus 3 is -5. And because -5 equals -5, I know it works for the first one. And then I want to do the same thing for the second one. So -1 plus 3 is 2, and -1 plus 3 is 2. So because 2 equals 2, I know that this is a yes. So it's a simple yes or no answer. Does it work or doesn't it? But it has to work in both. So obviously there are times where it could work in one and not the other. That would not be a solution. So will you get a quiz question like this? No. Okay, but can you check every single question on this stuff? That's the idea behind it. All right, if you're finding a solution from a graph, so you have the graph in front of you and you want to figure out what the solution is, you're looking for where your lines or your line and your parabola or your parabola and your circle, whatever the shapes are, where they intersect, okay? So you can graph both of them on the same coordinate grid, and then where they intersect would be your answer. So in this case, this little spot here where these intersect is my answer, and then this is for -1, so my answer would be written exactly like that for -1. So sometimes you'll be asked to graph it and then find your answer by hand. Sometimes you'll be asked to graph it on your graphing utility and find your answer, and sometimes you'll be asked to solve it using substitution and then check it with the graphing utility. The first one we're going to do is substitution. So solve one of the equations for one of the variables, and it doesn't matter which one. And then plug that expression into the second equation in place of the variable you just solved for. Solve for that new variable, the one that's left. And then you're going to take that answer, you're going to plug it back into the equation you solved for. So there are two special cases with substitution. There's going to be two special cases with all of the different types. But with substitution, what will happen is if you're going to solve, your variables will end up canceling out, and you'll have just a numeric answer left. If that numeric answer is true, like 1 equals 1 or 0 equals 0 or 2 equals 2, then your answer is all real numbers. Any pair of solutions would work in those equations. If what's left is false, like 1 equals 0 or negative 3 equals 0 or 5 equals 10, then your answer is no solution, and there's no number combination that would work for both. All right, so example 2 says solve using the substitution method. So notice that it's going to give you like substitution graphing right now. Obviously, if those directions say that, you want to do that. For the quiz, you're going to be forced to do one of each kind at least. If at the end of the chapter you just get the word solve, then you can choose which method you want to choose, okay? So let's say we're doing substitution this time. I want to look at my 2 equations and I want to figure out which one is easier to solve for which variable. Obviously, you want to look for things like isolated variables, positive variables, that kind of thing. So from these, which one would you choose? I probably would have done the y in the first one. Does everybody see that? Not that the x is wrong, okay? But the x is negative, so it's an extra step because you got to change the sign. Sometimes you can't avoid it, but this time we're going to take this and we're going to solve it for y. So I would get y equals 9 minus 5x. And then I'm going to take that and then I'll plug it into the other equation in place of the y. So I'd get negative x plus 3 times 9 minus 5x equals 11. Distribute the 3, so negative x plus 27 minus 15x equals 11. Combine your like terms. Negative 16x plus 27 equals 11. Negative 16x equals negative 16. And x equals a positive 1. Now I'm going to take that and plug it back in. And honestly, you could plug it back into this one. You could plug it back into this one. Or you could plug it back into the one that you tweaked already, which will automatically give you y. So that would be my recommendation, but again, it doesn't matter. Y would equal 9 minus 5 times 1, and y equals 9 minus 5, so y equals 4. And then your answer is going to be given in coordinate point format 1, 4. Make sure you don't switch those up. Make sure you do the x first, the y second. That's an easy mistake to make. And with extra time, you can easily take those and plug them back into the original equations and make sure you're right. But again, with extra time. Good so far. We remember this, right? From like Algebra 1 and Algebra 2, yes? Okay. All right, this one says solve the system using substitution. Use the graphing utility to verify. So the first thing is notice that these are now, you're going to get decimals, you're going to get fractions, all that good stuff. My advice is with decimals, get rid of them, and with fractions, get rid of them. So with decimals, how could I eliminate the decimal from this first one? Multiply everything by 10. So however many digits it takes to get rid of the decimal, that's how many zeros you need. So this becomes 15x plus 8y equals 23. Don't forget to cross over the equal sign. I would say that's the biggest mistake people make. Then the second one, again, only one decimal point is the most. So again, I'd multiply by 10. And I'd get 3x minus 2y equals 1. Now I got to look at this system and say what's easiest to solve for. Okay, x in which one? Second one. So you would do 3x equals 1 plus 2y, and then divide everything by 3. And I get x equals 1 plus 2y over 3. And you could leave it like that, or you could split it and make it 1/3 plus 2/3. Doesn't matter, because we're plugging this in to this one. It might be easier to leave it how it is. So 15 times 1 plus 2y over 3 plus 8y equals 23. 3 goes into 15 5 times, and then I'm distributing 5. So 5 plus 10y plus 8y equals 23. 5 plus 18y equals 23. 18y equals 18, and y equals 1. There's my first variable. Take it and plug it back in. X equals 1 plus 2 times 1 over 3. 3 over 3, which is also 1. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So now the second part of this said use a graphing utility to verify. So if I come back up to my system, first of all, I would go to the one that was we already got rid of the decimal, okay? But in order to plug these into your calculators, you've got to solve them for y. So very few of our calculators, excuse me, can you change the variable? It does exist, but most of ours don't, which means we have to solve each of these for y. So I would get 8y equals negative 15x plus 23, and then divide everything by 8. So in my graphing calculator, I can actually type it in as negative 15x plus 23 divided by 8. That's the first one. And then the second one, negative 2y would equal negative 3x plus 1, and then divide it by negative 2. And then you could type that directly into your calculator. So I'm going to do that. All right, so we graphed it on the graphing utility. We typed in both lines. And then to identify where they overlap, this one's easy because it ended up right on that little spot, which is a whole number for each one. If it wasn't as easy and you double tap your screen, you can get intersections. It'll bring you to it. Or on your graphing utility, if you go to that menu, you'll see where it says intersections. You can do that and it will bring you to the point where they cross. So this one, notice it said solve it. Use the graphing utility to verify. Don't graph it first and then get your answer. Okay? Do the substitution because on a quiz you would not have your graphing utility. So do the substitution. You're just using it to check. All right, now we're going to talk about graphing. So if we were to graph, we're going to graph each line or function, whatever they are. So it could be a parabola, could be a circle, could be a square root, any of those, okay, cubic function. You're going to graph those, and then where the lines or those functions intersect is your solution. Just like before, there's two special cases. If the lines are parallel or the two shapes never intersect, then there's no solution. And if they end up being the same equation or you draw the lines and they would overlap, then your answer is all real numbers. So you can get parallel lines that never intersect. That's going to be no solution. You can get a parabola and a line never going to intersect, no solution. Okay, you could get a circle and a parabola. The circle up here, the parabola down here, never going to intersect, no solution. All right, so this time it says solve the system by graphing. So the first thing I'm going to do is put each of these into slope-intercept form, and then plot your points. So for the first one, solve this for y. I'd get negative 2y equals negative 3x plus 7, and then divide everything by negative 2. So positive 3 halves x minus 7 halves. And I'm going to have to graph that, so I'm going to change it to mixed number. That's the first one. And then I want to do the same thing for the second one. So negative 4y would equal negative 6x plus 9, and then divide everything by negative 4. And I get y equals, that would be a positive 3 halves x minus 9 fourths, or 2 and 1 fourth. Everybody with me so far? So you're solving, and then you're going to plot these points. So for the first one, I'm going to go to negative 3 1/2, which is here. And then my slope is 3 over 2. 1, 2, 3 over 2. I'm going to do it again. 1, 2, 3 over 2 so I can get a better line. If you run out of space on the right, you could have also reversed it, right? I could have gone down 3, 1, 2, 3, and left 2. Okay, it would still give you the same line. And then the second one is 3 halves x minus 2 and 1 fourth. So I'm going to start at 2 and 1 fourth. 3, 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. So what do we notice about these lines? These are parallel. Could you have gotten that before you even graphed them? How? Same slope, okay? If they have the same slope, you want to also compare their y-intercept, because if it's the same slope and the same y-intercept, it's the same line, all real numbers. If it's the same slope, different y-intercept, and it's one of these cases, this is a no solution, okay? If it says to graph and then find your answer, you still want to graph it. But if you can identify, if it just says to solve it, then you can identify that they had that that they're parallel from the beginning. You can save yourself the extra steps. Questions so far? Easy stuff, right? All right, now we're going to get, these are nonlinear, right? So I've got a squared, and if it's squared, if the x is squared, what kind of graph is this? Okay, so the first one you're going to solve, I'm going to set that equal to y. So I'm going to do negative y. Oops. Negative y equals negative x minus 4, and then multiply everything by negative 1. And I've got my first equation, y equals x plus 4. The second one, I'm going to solve for y. Negative y equals negative x squared minus 2. Multiply by negative 1, and I get y equals x squared plus 2. So let's start with the first one. Okay, positive 4, 1, 2, 3, 4. Slope is up 1 and to the right 1, or down 1 and to the left 1. Again, it doesn't matter which direction you go. Second one. So what do we know about this shape? What did we say that was? Parabola. What do we know about the transformations of this parabola? Shift it up 2 places, right? So I know that this is here, and I know that it's going to be something like that, but I don't know exact points, okay? You want to use your transformation to get ideas to narrow down the points you've got to plug in to get exact points, but you need exact points, okay? So if it looks like it's going to hit there, then my x there is negative 1. So I'm going to plug negative 1 into here. Y equals negative 1 squared plus 2, 1 plus 2, which is 3. So now I know exact point on that would be negative 1, 3. So I know this one, and I know negative 1, 3. So that is my intersection on that side. That's one of them. Now on the right-hand side, if I approximate it, it looks like it's happening somewhere between, if this is 1, this is 2, this is 3. It looks like it's happening somewhere between 3 and 4. So I'm going to try 3. Oops. And I get 311. That's way too high. So I've gone too far, which means I'm now going to try 2. And I get 2, 6. So I go to 2, 1, 2, 3, 4, 5, 6. There's the other point. So you want to use your transformations to give you an approximate, but you need to plug in to be exact. So my parabola is really doing that. And the 2 intersections, which are the 2 solutions, are negative 1, 3, and 2, 6. So again, you can get parabolas and lines. You could get lines and circles. You could get lines and quadratics. You could get square roots. All those graphs that we've covered so far this year, make sure you know how to approximate it by transformations, but then also you got to plug in some exact points. All right, this one says solve using substitution and then use a graphing utility to verify your results. So go ahead, you solve it using substitution. And I'll tell you the only one I would avoid is x to the third, right? You don't want to work with a cube root. But the other ones you can try. All right, so out of curiosity, how many of you solved the first equation for x? Okay, all right, so I'm going to do that. So this would be x equals y. And then I got to take, and you can plug back into either one, all right? So let's say, how many of you plugged into the x? Okay, how many of you plugged into the y? All right, so you could take either one, but if I say y equals x, then I can take that and I can plug it in here. Or if I said x equals y, then I can take that and I can plug it in there, okay? Just be aware. So like, let's just say that when I solved it, I got like x equals y plus 1, for example, right? When you took this and plug it in here, you'd have to expand and FOIL that out. Okay, so you could see something like that. Just make sure you know that you're not like just distributing your cube. You have to expand and FOIL it out. It didn't happen this time. So I'm going to take, I think more of you raised your hand for plugging it into here. So I'm going to say that x to the third minus x equals 0. All right, so now how do I solve that? Take out an x. Now what? Difference 2 squared, so that's x plus 1, x minus 1. And now if any of those are 0, then it makes the whole thing 0, which means this is 0, -1, and 1. So I'm going to have 3 answers. One is when x is 0, one is when x is -1, and one is when x is 1. The easy part about this is the plugging in, right? So I'm going to take this one. So if x is 0, then y is 0. If x is -1, then y is -1. And if x is 1, then y is 1. So we think that when we graph this, we're going to get these 3 points, okay? If you think about it, if you had to actually graph this, right? First of all, y equals x would be a line that goes straight through my origin like that. And then this one, if I got -y equals -x to the third, I'd get y equals x to the third. This is a parabola not a parabola, a cubic function that's going to do something like that. So that's what we think is going to happen. If you look at that, it looks like it crosses it 3 times, which is consistent with what we found. So now we've just got to graph it. So here's our graph, and we see the point -1, 1, 0, 0, and +1, 1. So what we found is verified. Questions on that one? All right, this one says, use a graphing utility to approximate all points of intersection of the graphed equations, that's what that should say, in the system, and then round to 3 decimal places. Verify by checking your results in the original system. So this time we're actually going to graph this using our graphing utility first, and then we're going to use the intersections to give the answers. So I'm going to graph it on my handheld so you can see it. Okay, so I'm going to type it in, square root of x, come outside that square root, plus 4, and then 2x plus 1. And then I hit graph. This one does the colors, okay, not all of them do the colors, but this one does the colors so that I know that the first one I typed in was the blue one. If I go back to the y equals, they're blue, and then the second one is red. So again, there's my graph. And then I want to figure out exactly where it crosses. So I'm going to go to second, trace, and I get that calc menu. And I'm going to go down to intersect. And then I'm just going to hit, it says first curve. Yep, I'm going to hit enter. Second curve, it's on it. Yes. Guess, yes. And it brings me directly to the point in which they cross, which is 2.25 for the x and 5.5 for the y. So my answer here is 2.25 and then 5.5. If you would graph 3 lines, let's say, and you wanted to see where 2 of them intersected, that's why it says first and second. You would pick first, you would pick second, and then let it guess, okay? These we're only going to have the 2 in there, okay? But you could also set up just like we did with, let's say it crosses it more than once. Remember, you could set up your left bound and your right bound to find your intersection, okay? Same thing here. This time it terminated. We didn't have to round it, but if it went past that 3 decimal places, it said to round it. And then this one also says to verify by checking results into the original system. So if I take this is my x and this is my y, and I would get 5.5 equals the square root of 2.25 plus 4. If you think about 2.25, that's like the 225. This would be 1.5 plus 4. Which is 5.5. So it works for the first one. And then the second one, y is 5.5. 2 times 2.25 plus 1. 2 times 2.25 would be 4.5. And 4.5 plus 1 is 5.5. So it works. Because we didn't have to round, these should be exact. Okay. If we rounded, obviously, it might be a little bit off. It doesn't make it wrong. Okay. It's just because you rounded. Questions so far? So they're not always going to be pretty even numbers, okay? Sometimes they're fractions, and you're going to keep them as fractions that are simplified. And then sometimes it will tell you to round, and you'll round. All right, now we've got some applications. So there's a couple different types of word problems dealing with systems of equation. The first is interest. So if you're trying to find, we've talked about like we did that back when exponential, right? That was when it was compounded, or if it was compounded continuously or a number of times a year, okay? Those are all not simple interest. Simple interest is just 1 year, one rate. So all we have to do is find out how much money you invested times the rate. That's what simple interest is, okay? So this question says, if you're given the yearly interest earned from a total of $12,000 invested in 2 funds, paying the given rates of simple interest, write and solve a systems of equation to find the amount invested in each rate. So the interest itself is $500, sorry, and rate 1 is 3% and rate 2 is 5%. So if I can say that I've got 2 different rates, and X is the 3% one and Y is the 2% or 5% one. Those are my 2 variables. Now this piece of information says the interest earned is $500. So I have to figure out how much money was invested at 3% and how much money was invested at 5%, right? The interest earned at 3% is going to be my 3% times however much money I invested at the 3%. The interest earned on the 5% account is going to be 5% times however much money I invested at 5%. And then the interest earned is $500. So that's one equation. So the price or the amount of money you invested at each percent, right, added together, times their rate, added together is going to give you the interest. What other piece of information do I know? The total invested is $12,000. So X plus Y is $12,000. Now I've got a system. You with me so far? Mm-hmm. So the first thing you got to do is change your rate to decimal format. Don't forget to do this. This is one of the most common mistakes. So what is 3% in decimal format? 0.03 times X. And 5%? 0.05Y equals 500. So now I've got this system. Are you going to want to graph this? No. Okay, use substitution. After tomorrow, you can even use elimination if you wanted to, but for now, we're going to stick to substitution. So maybe the first thing I would recommend before you start plugging them in is to get rid of these decimals here. This time I'd have to multiply by what? 100. And be careful, because second most common mistake is not going all the way across the equal sign with that 100. This is 3x plus 5y equals 500. Tack on 2 more zeros, so 50,000. So now I'm using this and this. So substitution, what's going to be the easiest to solve for? Good. On the top. Yeah. So let's just say I want to take that one, and I want to say that x equals 12,000 minus y. And I'm taking this, and I'm plugging it into this x. So 3 times 12,000 minus y plus 5y equals 50,000. Distribute that in. Subtract your 36, well, combine like terms and then subtract. And I get 2y equals 14,000. Divide both sides by 2. And I get y equals 7,000. So I've got 7,000 invested at the y was 5%. Now how do I know it was invested at 3%? Plug it back in. The easiest one, x equals 12,000 minus y. So 12,000 minus 7,000 is 5,000. So with the scientific, like you're not going to, I'm telling you right now, you're not going to have a graphing calculator for this portion. You may have a scientific calculator. With a scientific calculator on this is super easy to check. I would do 7,000 times 0.05, 5,000 times 0.03, and see if those two numbers add up to give me my interest earned, which is 500. So these are quick, easy to check kinds of questions. All right, then we get break even. So a break even is used a lot in like companies that want to like figure out, or entrepreneurs, okay, that want to figure out how much they have to sell of something in order to break even, okay? So there's two different kinds of functions. One is called the cost function and one is called the revenue function. So the cost is how much, exactly how it sounds, how much it costs for you to run that thing, to sell the shirts, to sell cars, to sell whatever it is, right? Usually with cost, there's some sort of upfront, like a set fee, okay? If you wanted to, like I said, sell cars for a living, you'd have to buy the dealership. That's going to be your upfront cost. And then, if however much it is per item, would be your variable cost, okay? So if this one is, it costs $250,000 to start up this business, whatever it is, plus $8,650 per unit sold. That's how you set up your cost function. So this one's given to you, but sometimes it's going to make you set up your cost function. The revenue is what you're selling those things for. So where do you bring money in? So the revenue in this one is they're saying, okay, for each item I'm selling it as $9,950, okay? Does that make sense? Sometimes you got to set up the cost and the revenue. The break even occurs when you set these equal to each other, when your cost equals your revenue, okay? So it is a system in that they both have two variables, but really you just set them equal to each other and solve, because we're saying that C and R, we want to be the same thing. So I'm going to say 8,650x plus 250,000 equals 9,950x. So I want to find where these are equal. So I'm going to subtract the 8,650 divide both sides by 1,300. With a calculator, you could just type it in. Without, you'd want to reduce. Divide. So this is once. 9 times. Two times. Oops, not 0 yet. 3 times. Okay, so we're at approximately 192.3, okay? Now notice it says to round to the nearest whole unit, okay? If I just gave you 192.3 and asked you to round it, what would be my answer? 192, okay? Think about the real world application here. We're trying to find where you're going to break even. If you sell 192, whatever this is, have you broken even? Has your income met or surpassed your cost? No. So break even ones, think about the actual real world application. You need to figure out how many items it would cost where you are no longer losing money. So how many items do I have to sell? 193. So break even, you're never going to round down. Does that make sense? Even if it was 192.01. So I need to sell 109. Okay, since we're not rounding down, we would say the number of units that we need to sell is 193. And if we sell that much and it asks for the revenue, we're going to take it and plug it back in here. Okay, and then we just said revenue is what you're bringing in, okay? If you subtract that, if you subtract the cost from that, that's where you get your profit. Questions on that one? All right, this last example is one of the applications of the word problems for systems. It says the perimeter of a rectangle is 30 meters and the length is 3 meters greater than the width. Find the dimensions of the rectangle using a systems of equation. So one of the things to note is that you can actually solve this without using a system, but it's asking you to do that. So we're going to set up the system first and then solve it. The first piece of information that you need is obviously what the perimeter of a rectangle is. So that equation is perimeter equals twice the length plus twice the width. And in this one, it says that that is equal to 30 meters. So 30 equals twice the length plus twice the width. My two variables this time are length and width. The second piece of information it gives me is that the length is 3 meters greater than the width. So the length equals 3 meters greater than the width, 3 plus W, or W plus 3. So now I have my system, and I want to solve it. It's already set up for substitution. The L is already solved for here. So I'm going to take this, and I'm going to plug it in the place of the L in my original equation. So 30 equals 2 times 3 plus W plus 2W. Distribute the 2. Combine your like terms. Subtract the 6 from both sides. And I get 24 equals 4W. Divide both sides by 4, and W equals 6. So the width is 6. And then if I want to find the length, I would just say the length is 3 plus 6. So the length is 9. If it asks for dimensions, it could ask for length times width, which would be 6 meters by, or sorry, that's width times length. So 6 meters by 9 meters, or length times width, 9 by 6 meters. You'll see in WebAssign it will ask for the shorter side, the longer side, that kind of thing. And these are easy to check because, again, if it's 2 times 6 or 2 times 9 plus 2 times 6, I'd get 18 plus 12, which gives me 30. That's the end of the notes for 7.1.